Hello and welcome to this level question clip looking at this time the topic of carbonyls. It's quite a simple one this time because you just have to do two descriptions and it tells you which three substances you've got to work with. Although at first it looks simple, it's important to read the question as always before you plan what you're going to do and then carry your plan out. So simple test tube chemical test means that just that. It has to be something you can do in a test tube that you'll come across in your specification. So that basically means no spectroscopy such as infrared or NMR, because if you're thinking about doing this in a university-style laboratory, you'd have access to that kind of equipment, so it would be reasonable to propose that. But this time it says because it's a simple test tube chemical test, you have to keep it to something that would involve just simple test tube chemistry. So the first thing that will come to mind will obviously be something like toluenes or 2,4-DNP. And depending on what specification you're using, your specification at A-level may also mention something like failings test. So you've got three possible options. If you did an OCR specification, you wouldn't have come across the failings test, so you can ignore that. So you need something to distinguish the aldehyde from the other solutions. So the most obvious one would be toluenes. And failings test won't identify aromatic aldehydes, and it hasn't really told you in the question whether your aldehyde is aromatic or not, so that would be a bit of a blind alley to go down as well. So we've got two subheadings that we can break our answer down into. One subheading will be the section where we talk about distinguishing the aldehyde, and the other subheading will be the section where we talk about identifying the aldehyde. So our plan is now starting to take shape. We've eliminated the failings test, and we've eliminated also 2,4-DNP at this point. So our answer so far takes us to this point. We also need to think about the way the question says including relevant equations. So it would be quite easy to miss out the possibility of the question wanting more than one equation, because it says relevant equations, which is plural. So we've done one equation. The other equation is obviously the oxidation of the aldehyde. So what I suggest doing is putting in the equation for that as well. Just use R to represent any organic group. So when it comes to identifying the aldehyde, we need to say that 2,4-DNP, when warmed with separate samples of A, B and C, will only form an orange precipitate with the aldehyde and the ketone. So therefore you haven't really identified the aldehyde just by doing that. So what you've got to do is take this precipitate. So what happens is the 2,4-DNP gives a 2,4-dinitrophenyl hydrazone precipitate which has a sharply defined melting point. So you have to isolate the precipitate by filtering it under reduced pressure, then recrystallizing to purify and refilter it. And then what you can do with this refiltered precipitate, which is the pure sample, is test its melting point. And what you do then is compare that to known data. Okay, so that brings us to the end of this short clip. Like I said, it wasn't a terribly difficult one, but you have to be a little bit careful reading the question. So thanks for listening, and until next time, see you soon.